5.1.1 says let's determine without using a calculator the value of the following, and then we're starting with tan of alpha. We know fully well that tan of an angle theta is equals to opposite divided by adjacent, right? The opposite is the y and the adjacent is the x. So tan of alpha will become the y of our coordinate of interest t here, right? Which is minus 2 divided by x, which is minus 1. So tan of alpha is basically just equals to 2. And then 5.1.2 says let's find cos of theta. Maybe now you'd want to pause the video and try it out by yourself. Assuming that you did that, we know that cos of theta by definition is equals to the adjacent divided by the hypotenuse. So we have x divided by r, right? We've already established that we're using our point of interest t, right? So x will be equals to minus 1, and now let's find r. We know fully well from Pythagoras that x squared plus y squared is equals to r squared. So x is minus 1, we square it, and then y is minus 2, we square it, and that is all equals to r squared. So we basically take in the square root of 5 and say it is equals to r. So now cos of alpha will be equals to x, which is 1 minus 1 divided by r, which is square root of 5. And we can move to 5.1.3. So 5.1.3 says cos of alpha plus 45 in its simplest form. So we have cos of alpha plus 45 degrees in its simplest form. Let's not forget, we're supposed to do this without using a calculator, right? Now it will be a good time for you to pull out your trig identities, right? Because we know fully well from definition that cos of A plus B will be equals to cos A multiplied by cos of B minus sine of A multiplied by sine of B, right? From definition. And that's exactly how we're gonna do this question, because there's no way we can compute this as it is without using a calculator or changing it to this trig identity that we're introducing. So now we're gonna say cos of alpha plus 45 will be equals to cos of alpha multiplied by cos of 45 minus sine of alpha multiplied by sine of 45. So what is cos of alpha? We know fully well that that is minus 1 divided by the square root of 5. And then what is cos of 45? That is a special angle, right? That is 1 divided by square root of 2 minus sine of alpha, right? So what is sine of alpha? Again, let's go back to our definitions. We know that sine of theta is equals to opposite over hypotenuse. So that is y divided by r, right? So let's just plug that in. So we're gonna have minus y, which is minus 2, and then r, which is square root of 5. And then sine of 45. Sine of 45 is a special angle, square root of 2 divided by 2. And then let's erase this and carry on with our question. When I get to this point, I don't want to solve anything by head, right? I don't want to make any unnecessary mistake. I just put it in my calculator and get my answer, right? So I just did that, and I'm getting 1 divided by the square root of 10. And then 5.2 says that let's determine without using a calculator the value of the following expression. We have 2 sine of minus 20 degrees multiplied by sine of 160 degrees minus cos of 40 degrees. So this equation, as soon as it says without using a calculator, I'm going to use a calculator first, and then I'm going to get the answer. After I get that answer, I will basically be proving that that answer is true, right? So when I put this on my calculator, I'm getting -1. So whatever I do, however I solve this equation, I must get -1. If I don't get -1, there's something wrong I'm doing, right? So let's solve our equation. So this is equals to, so we have 2 sine of -20 degrees, right? What can you do to 2 multiplied by sine of -20 degrees? You can't do really much. So we're just gonna have 2 sine of -20 degrees. And then we have sine of 160 minus cos of 40 degrees, right? So we've already seen that we cannot do anything to sine of -20 degrees. And we need -1 some way, somehow. So if we could get -1 and -2 sine of -20, we're going to have our answer as -1, right? So we need to take everything else and push it towards 1 and sine of -20, right? That way we are getting close to our answer of -1. So what can you do to sine of 160? We know fully well that sine of 160 is basically sine of 180 minus 20 degrees, and then minus cos of 40 degrees. Let's leave cos of 40 degrees like that just for the moment. So 2 sine of -20, that's the same as -2 sine of 20 degrees. And then sine of 180 minus 20. So we are in the second quadrant, right? 180 minus 20 degrees. We know fully well that sine is positive on the second quadrant. So we can write that as sine of 20 degrees. And then now let's look at cos of 40 degrees. We know that cos of 2 theta is equals to 1 minus 2 sine of theta squared, right? Here we have 40 degrees, right? So cos of 2 multiplied by 20 degrees is equals to 1 minus 2 sine of 20 degrees squared. So in place of cos of 40 degrees, we can put 1 minus sine of 20 degrees squared, right? So let's go ahead and apply that idea. So here we're going to have minus 1 minus 2 sine of 20 degrees squared, right? And then that will all be equals to, so we have minus 2 sine 20 degrees multiplied by sine of 20 degrees. That will be minus 2 sine of 20 degrees squared, right? Minus, so let's solve that bracket. So we have minus multiplied by 1, that will be minus 1. And then minus multiplied by minus, that will be plus 2 sine of 20 degrees squared. So we have a minus 1 here. Here we have minus 2 sine of 20 degrees squared. Here we have plus 2 sine of 20 degrees squared. So it should be obvious now that our answer will be minus 1. The other 2 will cancel out. Now we can move to 5.3. 5.3 says consider, and we're given an expression, and then we are told to simplify that expression to a single trigonometric ratio. So let's write that expression down. We have 3 cos x multiplied by sine x, and then plus tan x multiplied by cos of 180 minus x squared, right? And then we're supposed to simplify it. So let's see what we can do. That will be equals to 3 cos x. What else can we do? There isn't much. So 3 cos of x, and then multiply by sine of x. Still not much you can do. plus tan x. You can play around with tan x, right? We know fully well that tan x is equals to sine of x divided by cos of x. So let's put that in. So we have sine of x divided by cos of x. So we just want to see if that will take us anywhere. It's not all the time that when you have tan of x, you must do this. Sometimes you have sine of x divided by cos of x and you change it to tan of x, right? We just try our luck and then multiply by cos of 180 minus x squared. 180 minus x, we on the second quadrant, and on the second quadrant it's sine that is positive, not cos, right? So here we're gonna have multiply by minus cos of x squared, right? It's only fair. So now we're gonna have 3 cos of x multiply by sine of x plus, right? And then now we can cancel cos of x with 1 cos of x here, right? So we're gonna be left with sine of x multiply by cos of x, and then we're not dividing by anything because on the denominator we had cos of x and they cancel out, right? Now you might be asking yourself, where did the minus go to, right? It just disappeared. The minus didn't disappear, right? We have a square here, right? We're taking this to the power 2. So if you square anything, the minus has to go, right? Maybe the mistake I did here is that I put it outside. It should have remained here, right? But then that minus is gone because of the square. So now we have 3 cos x sin x plus sin x cos x. So that will basically just be equals to 4 cos x sin x. Look at it and tell me if it doesn't make sense. So now we have 4 cos x multiplied by sine of x. So we can apply another trig identity. In trigonometry, you have to know all the trig identities by heart. There's no other way. So we know fully well that sine of 2 theta is equals to 2 cos theta multiplied by sine of theta. If you multiply both sides by 2, so multiply this by 2, multiply this by 2, you get 2 sine of 2 theta is equals to 4 cos of theta multiplied by sine of theta. And that's exactly what we have here. 4 cos theta sine of theta, but we have x instead, so that will be equals to 2 sine of 2 theta, right? And we have simplified our expression into a single trigonometric ratio. We can move to 5.3.2. 5.3.2. 5.3.2 says write down the range of f of x is equals to the expression we basically had, right? So in place of f of x, we can just put 2 sine of 2 theta, right? And then now we have to go to the basics. We want the range of that function, right? We know that the range of sine theta is -1 and we go up to 1, right? And then if you multiply by 2 here, then the range will also go up by 2, right? Its highest point will then be 2 and then its lowest point will be -2. So here we're gonna have a range. Y will be an element of some -2 to some 2 there. And then we can move to 5.4. Cos 3x divided by cos x is equals to 4 cos of 2x minus 3, right? So the rule of thumb when you solving trig identities is to pick the most complicated side, and then from the most complicated side you reduce it so that you get the simpler side, right? If you pick the side that is more simple, then it's very difficult to complicate it. So which side is complicated between the two sides? The left hand side is more complicated, right? We have a division there. It will be very difficult to produce a division from this expression, right? So let's take the left hand side and try and make it look exactly the same as the right hand side. So what is our left hand side? We have our left hand side being equals to cos of 3x divided by cos x. But there's nothing special about cos of 3x. So there isn't so much manipulation we can do to cos of 3x. So instead, let's say cos of 2x plus x. And then we can divide all of that by cos of x. So now it should be clear that we can play around with cos of 2x plus x because we know that there's something special about that. We've already established what cos of a plus b is equals to. So we'll just go ahead and substitute it. But let me just write it down for the faint-hearted ones. So we're basically saying cos of a plus b, right, is equals to cos of a cos of b minus sine of a sine of b, right? It's on the back of the question paper when you're writing your exam, right? And then now we have that being equals to cos of 2x cos of x minus sine of 2x sine of x, and then we divide everything by cos of x. But we know for the world that there's something special about cos of 2x, right? And then there's also something special about sine of 2x. But then let's not forget what we're trying to achieve. We have 4 cos square x. We have 4 cos of x squared minus 3, right? So let's break these terms, right? So we're gonna have cos of 2x cos x divided by cos of x, and then minus sine of 2x sine of x divided by cos of x. Check it out and tell me if it doesn't make sense. So let's move forward. This will be equals to, so let's change cos of 2x to sine, because on the other hand we have sine, right? And then on our solution there is no sine, so that sine has to disappear somewhere somehow. So we know that cos of 2x will be equals to 1 minus sine of x squared, right? So we're gonna have 1 minus 2 sine of x squared multiplied by cos of x, everything divided by cos x. Cos x. I'm sure you can see now that the division is falling away, right? We've gotten rid of it on this side. And then minus sine of 2x multiplied by sine x divided by cos x. Let's change sine of 2x to something that has cos, so that the denominators can also cancel out, right? And then we know fully well that sine of 2x is equals to 2 sine of x cos of x, and then we still multiplying by sine of x, right? I'm just running out of space. Everything divided by cos of x. So cos of x cancel out with cos of x, so we are left with 1 minus 2 sine of x squared minus 2 sine of x multiplied by another sine of x, right? So that will be just sine of x squared, right? But our answer has cos of x, right? So let's change sine square x to cos of x. Now, how can we do that? We know that sine square x plus cos square x is equals to 1. So if we do that, we're gonna get 1 minus 2. So we have 1 minus cos of square x, right? Minus 2 multiplied by 1 minus cos of square x. And then if we simplify this, we should get what we are required to prove. So we're gonna have 1, and then we have minus 2 multiplied by 1, so that will be minus 2. Then minus 2 multiplied by cos of x squared, that will be plus 2 cos of x squared. And then the other bracket, we're gonna get minus 2 multiplied by 1, that will be minus 2. Then minus 2 multiplied by cos of x squared, that will be plus 2 cos of x squared. So if we add all that, so we have 1 minus 2 minus 2, so that will be minus 3, right? And then we have 2 cos of x squared plus 2 cos of x squared, that will be 4 cos of x squared. And we've proved exactly what we are required to prove. Let's move to 5.5. 5.5 says that let's determine the general solution of x in the following equation. Which equation do we have? We have 3 to the 2 tan x minus 3 to the tan x plus 1 being equals to 54. So when I see a question like this, I always look for the easy way out, right? Usually the easy way out is writing this 54 in terms of 3, right? If you can write that 54 in terms of 3, then you can just, find a way to drop the basis and then you just work with the exponents. But then it's so bad that we cannot do that, right? So we have to find another way of solving this. So let's say let 3 to the tan x be equals to k, right? Because 3 to the tan x is just a lot to process, but then k is just simple and straightforward. If we do that, we're gonna get, in place of 3 to the power 2 tan of x, right, we're just gonna get k squared, right? You can work that out and see if it makes sense. I think it does. And in place of minus 3 to the power tan of x plus 1, so let me break that down for you first, right? So 3 to the tan x plus 1 is the same as 3 to the tan x multiplied by 3, right? So here we're gonna have minus 3 multiplied by k, and then that is all equals to 54, right? So now we can take 54 to the left hand side. We're gonna get k squared minus 3k minus 54 is equals to 0, right? So now we can factorize this. So we have k is equals to 0. So the question I ask myself when I'm factorizing, which two numbers do I multiply and get this value here, minus 54, and then when I add them I get minus 3, right? Factors of 54 that I can do that with. Those factors are 9 and 6, right? Minus 9 and 6. So we have minus 9 and 6. So k will be equals to 9, or k is equals to minus 6. But what is k? We know fully well that k is 3 to the tan of x, and then we also have 3 to the tan of x on this side being equals to minus 6. This part falls away. It's wrong. It cannot be true. So we are only left dealing with that. So 3 to the tan of x will be equals to 3 squared. Now we drop the bases, right? So tan of x is equals to 2, right? So we can say x is equals to tan arc of 2, right? Tan arc of 2 is 63.43 degrees. But tan of x is not only equals to 2 on that range, is equals to 2 every cycle it completes at some point of time, right? So the right way of writing it, you say that x is equals to 63.43 plus some constant k multiplied by 180 degrees, right? And then 180 degrees is the range of tan, right? And then K should be a whole